Hello everyone, in this video we're going to explore topic 8.2 precision, velocity and acceleration using indoors. Hopefully you recall some of our discussion about the concept of the particle motion from Unit 4 last semester. Now we have added the ability of using iteration to our toolbox. We can do so much more with this idea. Recall that in our study of particle motion, a particle moves along a horizontal line so that its position at time t for t greater than or equal to 0 is given by s of t, or oftentimes s of t like this: velocity v of t and acceleration a of t, right? Now let's take a look at this example. Your teacher moves along a straight line at the front of the classroom according to the values in the table below. Time is measured in seconds and s of t is measured in cubic squares. Question 1. How far was your teacher's ending position from his starting position from t equals 0 to t equals 4 seconds? Alright. So you need to find the displacement between the ending position and starting position, right? So you have s of 0 right here equals 2, right? Now s of 4 equals 18, right? Now you need to take s of 4 subtract s of 0. It's going to be 18 subtract 2. It's going to be 16 cubic square. Alright, question 2. What is the distance your teacher traveled from t equals 0 to t equals 4? Alright, so you need to calculate the absolute value of s from 0 to 1 first, right? S of 1 minus s of 0. It's going to be negative 2 minus 2, right? Absolute value of negative 2 minus 2. It's going to be 4, right? Now, from 1 to 2, you have s of 2 minus s of 1, right? It's going to be absolute value of 0 minus negative 2, which means 0 plus 2, right? It's going to be 2. Next, from 2 to 3, it's going to be s of 3 minus s of 2, right? Equals absolute value of 2 minus 0. It's going to be 2. Next one, from 3 to 4, s of 4 minus s of 3 equals 18 minus 2. And it's going to be 16, right? Now you're going to add all up this guy, this guy, this guy, and this guy. So it's going to be 4 and 2 and 2 and 16. The answer is 24 cubic square. Now let's take a look at example number 1 right here. Particle motion with technology. Alright. This one is calculator active. Alright. A particle moves along a horizontal line for t from 0 to 8. The velocity of the particles is given by v of t equals this guy, and the position is given by s of t. It's known that s of 0 equals negative 3. So this one is the starting position, right? Now, question 8. Find all values of t in the interval 4 to 7, for which the speed of the particle is 5. So, remember, when we talk about the speed, we talk about the absolute value of v of t, right? And this guy must be equals 5, right? Now, we're going to bring up the calculator. We need to store the function right here so that it's going to help us to calculate B, C, D, right? So we're going to add calculator. Alright, so you're going to hit V of. Now in this situation, I'm going to use the variable S because I'm going to graph v of t on the x and y coordinate plane later, right? So I'm going to use s as the variable. It's going to be the same thing, right? Then you're going to hit control and the button right here, right? So instead of t, I'm going to put s minus 3 times natural log of s plus 2, right? Plus 2 times s times sine of, now I'm going to hit the fraction right here. I'm going to pick this one, right? It's going to be s squared over 12. And I'm going to hit enter. Alright, I'm done. Alright, so basically I need to graph this guy and this guy on the same x and y coordinate plane, right? So I'm going to go to home screen, hit graph right here. F1 of s actually absolute value of v of s, right? So I'm going to hit the button right here to pick the absolute value side right here. Alright, so I'm going to put v of s. I'm going to hit enter. Excavate right here. Alright. Now the second one is 5. I'm going to hit tab right here. I'm going to put 5. I hit enter. Excavate horizontal line right here. Now I need to restrict the domain. The domain should be 4 to 7, right? So I'm going to go to menu, window zoom right here, window setting. S minimum should be 4. S maximum should be 7. Alright, hit enter. Alright, so I have two intersections right here. This guy and this guy, right? So I need to hit menu, number, set intersection right here. Alright, move to the left of intersection, move to the right of intersection. It's gonna be right here. 5.62, right? Now I'm gonna do exactly the same thing for the second one right here, right? So I'm gonna hit menu, number set, analyze graphs, intersection, move to the left, move to the right. The answer is right here. Set point 52. Alright. So I have two values, t equals 5.62 second and t equals 6.52 second, right? Now, question B. Write an expression involving an integral that gives the position s of t. Use this expression to find the position of the particle at time t equals 3. Right. Now you know that the starting position is s of 0 equals negative 3. Right? So you have s of t equals the starting position is going to be negative 3, right? Now you need to ask something. How do we find this one? Actually, we're going to take antiderivative of this one, right? So, because antiderivative of v of t is actually s of t, remember? So it's going to be integral from 0, right here. You see that? To t. We don't know t, right? Of v of s ds, right? Now we're going to use this one to calculate the position at time t equals 3, right? So we have s of 3 equals negative 3 plus the integral from 0 to 3 of v of s ds, right? So since you already saw the function, right? V of s right here. So you just calculate s of 3 using this one, right? So I'm gonna go to home screen, right? Hit calculate right here, right? So I have s of 3 equals negative 3, right? So I have negative 3 plus, right? The integral, I hit menu, go to calculus, integral right here, right? From 0 to 3 of v of s ds, right? Hit enter. The answer is right here. You need to convert this one to decimal, right? So I hit menu, number, convert to decimal, hit enter. The answer is right here. Negative 6.295, right? Now let's move on to question C. Find R times T in the interval from 0 to 8 at which the particle changes direction. Alright, now remember that the particle changes direction when the sign of v of t changes, right? We need to get the function v of t, right? So we're gonna bring up the calculator. We need to hit home screen right here, hit graph, right? Now I need to clear this one, so I hit tab and hit the upper arrow right here. I go to F1 right here. I need to remove absolute value sign, right? So it's gonna be like that, right? So I need to hit v of s. That's it, right? Hit enter. It's gonna be like this. Now I'm gonna hit tab again. I go to F2 of s right here. I need to uncheck this one, right? So my function should be right here. Alright, remember that the domain from 0 to 8, right? So I hit menu, go to the window setting right here. It should be 0 to 8. Hit OK. It's gonna be right here. Alright. Now observe that v of t changes direction when t equal this guy and this guy, right? Because for the part below the x-axis right here, it's gonna be negative. The one above the x-axis is gonna be positive, right? So it could be from negative to positive, which means it changes direction. And from here to here, positive to negative right here, it changes direction right here, right? So I need to find the zeros of the function v of s. That's my answer, right? So I need to hit menu, number 6 right here. I need to find 0, right? So it's going to be right here. I have the first 0, 2.34, right? I need to do the same thing for the second one, right? So hit menu, analyze graph, 0. It's going to be right here, 6.13, right? So you need to say that the particle changes direction when the sign of v of t changes, right? Then on the interval t greater than equal to 0 less than equal to 8. This occurs at t equals 2.34 and 6.13, right? Now let's move on to question D. Is the speed of the particle increasing or decreasing at time t equals 7? Remember, you learned from unit 4. If velocity and acceleration have the same sign, the speed is increasing. If the velocity and acceleration have opposite sign, then the speed is decreasing. Alright, so keep that in mind. Now, I need to calculate v of 7 first, right? So I'm going to use the calculator right here. I already have the function v, right? So I need to go to home screen, hit calculate v right here, right? So right here I just hit v of 7, right? Hit enter. The answer is right here. I need to convert this one to decimal, right? So I hit menu, number, convert to decimal, hit enter. The answer is negative 10.9, right? Now I need to calculate a of 7, right? This guy actually v prime of 7, right? So I'm gonna print up the calculator again, right? I need to hit menu, calculus right here, derivative right here. Variable s and value should be 7. Alright, I hit OK. I need to input v of s, right? V of s right here. And then I hit enter. Now convert this one to decimal. So hit menu, number, convert to decimal, hit enter. The answer is right here. Negative 10.5607, right? Now observe that v of 7 and a of 7 have the same sign, right? Negative, negative. Then the speed of the particles is increasing. Alright, the following table is fairly complete. in describing expressions that commonly seen in the particle motion problems. Now, expression on the left hand side and mathematical translation on the right hand side. If you see initial position or velocity or acceleration of the particle, then initial usually means at time t equals 0. We often know initial position, which means s of 0, initial velocity v of 0, or the initial acceleration a of 0 of the particle. Right? Now, particle is at position s equals s1 at time t equals t1. Right? This gives us the position of the particle at a specific time s of t1 equals s1. Right? Now, particle is at rest. Keep that in mind. This means velocity is 0. Right? V of t equals 0. Right? Now, particle is moving to the right. This means velocity is greater than 0. It tells us that v of t is greater than 0. Particles moving to the left, right? It's going to be opposite to the above. V of t is less than 0. Average velocity of the particles on the interval a, b, right? Remember, you learned this one in 8.1, right? It's going to be 1 over b minus a, integral from a to b of v of t dt, right? But the integral from a to b of v of t dt actually s of t, right? Because you're going to take antiderivative of v of t, you get back to the position function, right? And then you need to evaluate from a to b. Then does that mean s of b minus s of a over b minus a right here, right? Now, instantaneous velocity of the particle at time t equals t1. Then you have v of t1 equals s gram of t1, right? Because the velocity function is the first derivative of the position function. So keep that in mind. Acceleration of the particles at time t equals t1, right? You do exactly the same thing above right here. Take the first derivative of the velocity is the same thing as take the second derivative of the position function, right? So that's why you have s the problem of t1. Now, velocity of the particle is increasing. This means that the derivative of the velocity is positive. Alright, keep that in mind. This one is different from the speed right here. So be careful, alright? Velocity of the particle is decreasing, which means the first derivative of v of t is less than 0, right? The speed of the particles is the absolute value of the velocity, right? Because the speed always positive. So keep that in mind. The speed of the particle is increasing or speeding up. So it tells us that the velocity and acceleration must have the same sign, right? They both either positive or negative, right? Similarly, the speed of the particle is decreasing or slowing down. Velocity and acceleration must have the opposite sign, right here, right? Now, total distance traveled by the particle over the time interval a to b is going to be integral from a to b of absolute value of v of t dt. Right? Remember, total distance, it should be positive. Keep that in mind. Now, displacement of the particle or net distance traveled by the particle over the time interval a b equals integral from a to b of v of t dt, right? This one doesn't have absolute value sign, right? Because this one is displacement, right? Now, position of the particle at time t equals t2, right? Remember, t1 is the initial value, right? So you have s of t2 equals s of t1 plus the integral from t1 to t2 of v of t dt, right? Because when you take antiderivative of v of t, it's going to be s of t. Keep that in mind. And this one is the initial one, right? This one will be given. Keep that in mind. This one must be the same. Now, the particle changes direction. This occurs where the velocity of the particle changes from positive to negative, from negative to positive, which is, we did it right here, right? Now, the particle is farthest to the left or right, which means you need to find the maximum or the minimum value of s of t over an interval. You need to find the value of t squared, s prime of t1 equals v of t1 equals 0, which means you need to find the critical number, right? Then you need to consider the position of the particle at the critical points, and if the interval is closed, you need to consider the endpoint, right? So basically, for this one, you need to use the candidate test. Now let's move on to example number 2. The space shot is an amusement park ride that gently raises riders up a tower and then rapidly passes them up and down using compressed air. The velocity of the space shot for t from 0 to 14 is modeled by the piecewise linear function as shown below, where t is measured in seconds and v in feet per second. Question A. At what times in the interval t from 0 to 14, if any, does the space shot change direction? Give a reason for your answer. Alright, so we look at the graph right here. This one is the v of t function, right? Now, the space shot changes direction when v of t changes size, right? Now, it changes size right here, and right here. Why? Because this guy right here above the axis, which means it's positive. This guy right here below the axis is going to be negative. So positive to negative, right? And this one is negative to positive. This one positive to negative, right? So you need to say the space shot changes direction at t equals 6, t equals 8, and t equals 10 seconds, right? Because the size of v of t changes at this value, right? Let's move on to question B. At what times in the interval 0 to 14 is the space shot the highest, right? So we're going to talk about the position function, right? So I call position function is h of t, right? Now, in order to do this one, we need to find the first derivative and we need to find the critical number, right? And we need to use the candidate test, right? Remember? So I have h of t is the high function, right? Now we need to take the first derivative of h of t. It's going to be h prime of t. This guy actually v of t. Makes sense, right? So you need to find a critical point, right? You need to let this one equals 0, right? And we look at the function right here. V of t equals 0 when t equals 6, 8, and 10, right? So we have t equals 6, 8, and 10. Now look at the closed interval right here. We need to include the endpoints, right? So don't forget 0 and 14, right? So we need to use the candidate test, right? So we have the following table. Now h of t is the antiderivative of v of t, right? So it's going to be antiderivative of v of t dt, right? Now remember, we start from 0. So the lower bound right here must be 0. The upper bound right here is this number right here, right? Now since the lower bound and upper bound have the same value, this guy must be equals 0, right? Now next one, the interval from 0, right? You always start from 0. This one lower bound. Upper bound should be 6 right here, right? So it will be 6 v of t dt, right? Alright, so we need to take a look at the function v of t where t from 0 to 6, 0 to 6, which is the trapezoid right here, right? So we need to calculate the area of this trapezoid. Base 1 equals 1, 2, 3, 4. It's going to be 4, right? base 2 is going to be 6, right? From here to here. And the height right here should be 20, right? Remember, look, be careful. Alright, so we have base 1 plus base 2, 4 plus 6 times the height 20 divided by 2, right? So it's going to be red, right? Now, next one, we have the integral from 0 to 8 v of t dt, right? Now, 0 to 8, which means we need to subtract this guy because this one is below the axis, right? So we need to subtract the area of this triangle, right? So the base is 2, the height is 60, right? So whatever you got right here, 100 right here, you need to subtract base is 2 times height is 60 divided by 2. So it's going to be 100 subtract 60, it's going to be 40, right? Now next one, the integral from 0 to 10 v of t dt, right? So 0 to 10, which means we need to add this guy right here, right? The base is 2, the height is 40, right? So whatever you got 40 right here, you need to add the base is 2, the height is 40, and then you need to divide by 2. So it could be 80, right? And the last one, the integral from 0 to 14 v of t dt, right? So you need to subtract this guy right here, right? So the base is 4, the height is 40, right? So whatever you got right here, 80. Subtract the base is 4, the height is 40, right? Divide by 2. So it should be 0, right? Now, since you need the height is 1, which means the maximum value, right? So the maximum value is right here, 100, right? The space short is the height is at 100 feet at time t equals 6 seconds, right? Now question C, find the total distance. Remember, total distance must be positive, right? The space short traveling during the time of the interval 0 to 14, right? So we look at the formula right here. Total distance is going to be right here, right? So it can be integral from a to b of absolute value of v of t dt, right? So it's going to be the integral from 0 to 14 of absolute value of v of t dt, right? Now it's going to be the area of this guy right here. Add the area of this guy, add the area of this guy, add the area of this guy, right? Now the area of this guy should be 100. We recalculate it right here, right? The area of this guy equals 2 times 60 divided by 2. It's going to be 60, right? The area of this one equals 2 times 40 divided by 2. It's going to be 40, right? The area of this one equals 4 times 40 divided by 2. It's going to be 80, right? Now you need to add this guy up. So you have 100 at 60 at 40 at 80, right? The answer is 280 feet, right? Remember, be careful, the total distance must be positive, right? Now question D. Write expression for the right acceleration a of t, velocity v of t, and distance s of t from the ground that valid for the time interval 10 to 12, right? The interval from 10 to 12 is going to be this guy right here. So your graph should be this guy right here. Alright, now remember, this one is the velocity function, right? So if you take the first derivative of this one, it's going to be the acceleration, right? But the first derivative of v of t is actually the slope of the function v of t, right? So you need to find the slope of this one, right? So basically, rise over run, right? Now rise right here, you go down by 40, right? And go to the right by 2, right? So this is negative 40 and this is 2, right? So A of t equals rise over run, which means negative 40 divided by 2. It's going to be negative 20, right? Now, V of t, you need to use the point slope form formula. Remember, y minus y1 equals m times s minus s1 to write the function v of t, right? Now the function v of t, the slope is negative 20 right here. Remember the value of the acceleration, actually the slope of the function v of t, right? So we have minus, now I'm going to pick a point. I'm going to pick the point right here, 10, 0, right? Minus 0 equals the slope is negative 20 times t minus 10, right? Now I'm going to simplify this one. So v of t equals negative 20 t plus 200, right? This one is the function of the velocity, right? Now, what about the position function, right? Remember, initial value is 10, right? So we have s of t equals initial value is going to be s of 10 plus the integral from 10 to t, right? Of negative 20 s plus 200 ds. Remember, you need to change the variable right here to s, and then s of t right here depends on the value of t right here, right? So keep that in mind, right? We're going to use the formula right here. It's right here, right? Now let's move on to example number 3. A particle moves in a straight line with velocity v of t meters per second, where t is time in seconds. At time t equals 5, the particle's distance from the starting point was 6 meters. What is the total distance, right? The key word right here, total distance, right? So when it comes to total distance, think about the absolute value sign, right? The particles has traveled between t equals 5 to t equals 10, right? The answer absolutely C, right? The multiple choice 2. A particle moves in a straight line with the velocity v of t equals t squared minus 3t minus 7 meters per second, where t is in times in seconds. At time t equals 2, the particle's distance from the starting point was 10 meters in the positive direction. What is the particle's displacement? Alright, the key word right here, displacement, between t equals 2 and t equals 9. Alright, so it can be the integral from 2 to 9 of v of t. That's it, right here. Right? Very simple. Now, example number 4. Using the NUT. N stand for now. U stand for units. And T stand for time. Strategy to interpret motion integrals right here. Alright. Now, we have s of 2 plus the integral from 2 to 4 s prime of t dt. Right? At t equals 4 seconds. Right? Now, this one tells us that the position of the particle at t equals 4, right? In fit from the origin. Now, number 2 right here, the integral from 1 to 4 of s prime of t dt, right? So when you take the antiderivative of s prime of t, it tells us that this one is a change in position of the particle, because this one actually s of 4 minus s of 1, right? Now, the units right here should be in feet, right? and the time should be from 1 to 4 seconds, right? If you look at this one, actually the average value, right? Average value of the speed, right? Because absolute value of v of t, right? So you need to say the average speed of the particle. And time should be from 1 to 4, right? This one is similar to the one right here, right? So you need to say the position of the particle at t equals 2 right here. Remember, this guy and this guy must be the same. This one initial position, right? And t equals 2, right? Now look at this one right here. Absolute value of v of t, actually the total distance the particle has traveled, right? And the unit should be feet, right? Now the last one, this one actually the average acceleration of the particle, right? The unit should be feet per second square. Why? Because when you take antiderivative of acceleration, you get the velocity, right? So velocity, the unit should be feet per second, right? And then you divide by times right here, right? Which means you have feet divided by second times second right here. It's going to be feet over second square, right? That's why you get this one, right? Now the time should be from t equals 1 to t equals 4, right? And it's your time to solve. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.